Every star you have ever seen with your own eyes is, at its heart, the same simple thing. A giant ball of gas, crushing itself under its own gravity, hot enough in the core to fuse hydrogen into helium. That's a main sequence star. Our sun is one. So are the red dwarfs. Small, cool, and by far the most common. And the blue giants, dozens of times heavier, burning furiously and dying young. Change the size, the color, and how fast they burn, and you've covered almost every star anyone ever points to in the night sky. But here's the thing. These ordinary, shining stars are the tamest, simplest objects the universe is capable of calling a star. The real catalog gets much, much stranger. Starting with what happens after one of them dies. The corpses. When an ordinary star runs out of fuel, it doesn't just vanish. It leaves a body behind. And those bodies are stars too. Just dead ones. A star like our sun collapses into a white dwarf, an Earth-sized ember holding half the mass of the sun, so dense that a single teaspoon of it would weigh several tons. A heavier star dies far more violently, its core crushed into a neutron star, a ball only 12 miles across, yet heavier than the sun. Now that same teaspoon would weigh as much as a mountain. Some of them spin hundreds of times a second, firing beams of radiation across space as pulsars. And the most magnetic of all, magnetars, carry fields so violent they could scramble every atom in your body from the distance of the moon. These corpses are already strange, but at least they're made of matter we understand. Keep climbing, and even that stops being true. The vampire star. Some stars cheat death by stealing life from another. In a tight pair, one star can siphon gas straight off its companion, pulling fresh hydrogen onto itself and reigniting, burning hotter and looking far younger than it has any right to be. Astronomers call these blue stragglers, stars that should have burned out long ago, kept alive by feeding on a neighbor. In an ancient cluster where every star should be old and red, they stand out as impossibly young and blue, until you realize what they've been doing. They're not young, they're vampires. And if a star feeding on another sounds extreme, the next hybrid is far harder to even picture. Picture a star with another, denser star buried alive inside it. That's a Thorne-Zhitkov object. It forms when a massive red supergiant swallows a neutron star whole. And instead of being destroyed, the neutron star sinks all the way down to the giant's core and simply stays there, beating at the heart of the larger star like a second hidden engine. From the outside, it looks like an ordinary red supergiant. On the inside, it's running on physics no normal star uses, generating elements in ways a single star never could. For decades, these were pure theory, until astronomers found one real star that seems to fit. One star that might secretly be two. And from here on, we leave normal matter behind completely. Quark stars. Squeeze a neutron star hard enough, and something has to give. A neutron star is already matter crushed to its absolute limit. Neutrons packed shoulder to shoulder, as tight as particles can go. But pile on just a little more mass, and the pressure can become so brutal that the neutrons themselves shatter. They dissolve. What's left is a quark star, an object made not of atoms, not even of neutrons, but of a soup of raw, free quarks, the fundamental building blocks that are normally trapped inside other particles forever, suddenly exposed and laid bare. A strange star, as some are called, would be one of the densest things in all of existence, short of a black hole. A single, mountain-crushing object that is, essentially, one enormous particle. We're not certain they exist, but a handful of dead stars out there look a little too small and a little too dense to be ordinary neutron stars. And if quark matter can be crushed even further, physics already has a name for what comes next. If quarks themselves are secretly made of something smaller, particles physicists call preons, then in theory you could crush matter past even a quark star into a preon star. And here the density stops making any sense. A preon star with the entire mass of the sun could be smaller than a city, possibly smaller than a single mountain. A marble of its material would outweigh a planet. It would sit right at the very edge of what's possible before an object collapses into a black hole entirely, the last stop on the ladder of density. Now, preons might not even be real. This is a hypothesis stacked on top of a hypothesis. But that's exactly the point of this list. We've stopped asking which stars exist. We're now asking what a star is even allowed to be. And the answer gets stranger still when you stop using ordinary matter at all. Boson stars. Everything so far is built from matter, particles like quarks and electrons. But there's a whole other category of particle in the universe. Bosons, the particles that carry forces. And in theory, you could build a star out of those instead. A boson star would have no surface, no nuclear fire, no light of its own. It would be a smooth, ghostly, see-through ball of force particles, held together by gravity alone, utterly silent and very nearly invisible. Here's the unsettling part. From a distance, a boson star could be almost impossible to tell apart from a black hole. Some physicists suspect that a few of the black holes we've already detected might actually be these. And a boson star might even be built from dark matter, the invisible substance that outweighs every visible star in the universe combined. Which points us toward a star that may have been the very first light in all of existence. Dark stars. Long before the first normal stars ever switched on, the early universe was flooded with dark matter. And some physicists believe the very first stars weren't powered by fusion at all. They were powered by dark matter destroying itself. These are dark stars, enormous bloated clouds of hydrogen, kept glowing not by burning fuel, but by dark matter annihilating in their cores. And because dark matter was everywhere in those first few 100 million years, these stars could grow to monstrous sizes, not dozens of times the mass of the sun, but millions. trillions. A single dark star could outshine an entire galaxy on its own. They may be long gone now, burned out in the universe's opening chapter, but if they were real, they would be the largest, brightest stars that have ever existed. And when one of those giants finally collapsed, it may have turned into something we have only just started to find: black hole stars. This is the strangest star on the entire list, and it might be real. When the James Webb Space Telescope began staring into the deep early universe, it found something nobody could explain: tiny, intensely red dots, glowing far too brightly for what they seemed to be. After years of argument, astronomers landed on an answer that sounds impossible. These little red dots may be black hole stars, also called quasi-stars. Picture a giant ball of gas, the size of a normal star, but at its very center, instead of a fusion core, sits a black hole. The black hole feeds on the gas around it, and the energy it throws off as it feeds is what makes the entire object glow. A star, lit not by nuclear fire, but by matter falling into a black hole at its heart. One of the lead researchers called it the most exciting thing to come out of the James Webb Telescope. These may be how the universe forged its first supermassive black holes, and possibly what those collapsing dark stars became. A star with a black hole for a heart, and we may be looking right at them, 13 billion years in the past. For the final entry, we leave density behind and go all the way to the end of time. When a white dwarf finishes cooling, after trillions of years, it becomes a black dwarf, a cold, dark, dead star, totally invisible, drifting through an emptying universe. Not a single one exists yet. The cosmos is nowhere near old enough, but they are coming, and in the truly unimaginable far future, a span of time with over 1,000 zeros in it, something even stranger may happen. Over those timescales, the matter locked inside dead stars could slowly, atom by atom, rearrange itself into the most stable element there is: iron. The last objects in the universe may be cold, solid spheres of iron stars, sitting at almost absolute zero, in a cosmos so old that every other light has long since gone out. The final stars won't burn at all. They'll just rest there, frozen in the dark, forever. Here's what this entire list is really telling you. Every star you have ever seen, every point of light in every night sky in all of human history, is one of the ordinary ones, the tame ones, the boring ones. The strangest stars the universe can build are either still just equations on a page, or existed only in the first chapter of time, or won't appear until the very last. Quark stars, dark stars, black hole stars, iron stars. The true range of what a star can be is almost entirely hidden from us, scattered across times we cannot reach, and physics we can barely touch. The night sky was never the catalogue of stars. It's only the first page. And every one of these stars, ordinary or impossible, eventually dies. If you want to see exactly how, from the quietest fade to the most violent explosion in existence, that video's on screen right now. Subscribe, and we'll keep counting the things the universe doesn't want you to know.